Hello again, this is Mr. Sorrentino, coming to you with another video for Math 31, which deals, in this particular video, is going to deal with section 1.6, solving linear inequalities. An inequality is simply going to have a less than, greater than, less than or equal to, or greater than or equal to symbol in it, which indicates an interval of numbers that are answers rather than just one set answer or maybe even two set answers. There's procedures for this. However, basically it's still equation solving. The only difference is that you have to pay attention to instances where you're multiplying or dividing on both sides of your inequality. If I have to multiply or divide both sides of an inequality by a negative, then I have to switch the inequality sign around. Now, for these simple inequalities, the graph to solution set is kind of an afterthought because I really don't need to do it to come up with an answer. But when we get to more complicated inequalities later, having the graph of the number line is going to be useful because that's what's going to help us find our solution in a quicker, more effective way than some other methods that might be out there. For these, however, they're pretty straightforward. So focusing my attention on A here, and let me just scooch that over a bit. I want to solve the inequality 4 minus 7x is less than or equal to 25. So what I want to do here is I just want to get x alone on one side of an inequality here. So I'm going to subtract 4 from both sides. And so I'm going to have a negative 7x less than 25 minus 4, which is 21. Now I'm going to divide both sides by a negative 7. This is where I have to be vigilant. Anytime I multiply or divide two sides of an inequality by a negative number, not if I'm adding or subtracting a negative number, only if I'm multiplying or dividing by a negative number, I have to remember to switch around the inequality sign. So negative 7x divided by negative 7 is just going to give me an x. The 21 divided by negative 7 is going to give me a negative 3. Since I divided both sides by a negative, this less than symbol is going to become a greater than symbol. And so that's what my solution is. The solution is, this will be true for anything where x is greater than negative 3. Now when I graph these number lines, I never have to really make them super sophisticated, okay? I'm just going to say, okay, well here's negative 3. So you can say that's negative 2, negative 1, 0, 1. I'm just going to say where negative 3 is, okay? And for this solution, I'm not going to be able to equal negative 3, because if I equal negative 3, that's going to give me an instance where I have 4 minus 7x equaling 25. Equaling 25 is not being less than 25. So now I want it to be greater than negative 3, so I would shade everything to the right. And that would be the solution graphed on a number line. So a lot of the same equation solving things, this is more or less a two-step equation, using the same procedures for that. However, the only thing I have to keep in mind is to make sure that I switch around the inequality sign if I multiply or divide both sides by a negative. Let's try B. Very similar. I have x's on both sides. I like to get x on one side only. So I'm going to subtract 2x from both sides. Now I'm subtracting here, so I don't have to worry about switching any inequality sign around. 5x minus 2x is 3x. The plus 2, nothing happened to that because I didn't do anything with it, so that stays. I didn't multiply or divide both sides by a negative, so that stays the way it is. I have a negative 10. I now have all my x's on one side of the inequality, and I also combine like terms. So the left-hand side is as simplified as I'm going to get. Now I'm ready to get x alone. So I'm now going to subtract 2 from both sides. And I'm going to get that 3x is less than or equal to negative 12. X is still not alone or isolated on the left-hand side, so I'm going to divide both sides by a positive 3. Now I'm dividing by a positive number, which means nothing is going to happen to that inequality symbol. So 3, I'm not going to have the 3x anymore. 3 is gone. So I'm going to have x is less than or equal to negative 4. That's my solution. So on the number line, I'll say negative 4 is, say, here. It's a less than or equal to, so this is going to be a dot that is filled in because equal to does make this true. And if I put negative 4 on both sides, I do get a negative 18, I believe. Yeah, I get a negative 18. So that makes, both sides equal, and both sides being equal is, a true statement as well. And I want anything less as well included, so I'm going to shade to the left. So we're going over these skills about being able to graph inequalities on a number line because eventually the ability to do so is going to help you find answers later to much more complicated inequality problems. For C, the only difference in C is that you have a compound inequality separated. So basically all you have is two inequalities separated by an OR statement. It's not a big deal. You just have to make sure you know what an OR statement stands for, but let's solve each of these inequalities first, and then we'll worry about the OR. So, so this one here, I want to add 1 to both sides. I'll have 3x is less than or equal to negative 6. I'll divide both sides by 3. Since I'm dividing both sides by a positive number, nothing's going to happen to that inequality. And so I'm going to have x is less than or equal to negative 2. On this side, I'm going to add 1 to both sides. And I end up with 3x being greater than 21. I'm going to divide both sides by 3 to get x alone. Again, I'm dividing by a positive value, so I'm going to have x being greater than 7. And this OR statement just kind of just rides its way all the way down, which means x is less than or equal to negative 2 or x is greater than 7. Now an OR statement means I only have to obey one at a time. If both happen to work, great. If not, oh well. So again, I don't have to be that super accurate with it, but basically the inequality is going to have a closed dot here at negative 2 and anything to the left of it. Or at 7, an open dot and anything to the right. An OR statement often looks like this because it's saying that I have two different options. Either I'm going to have a value that's negative 2 or less, or 7 or more than 7. I can't be both at the same time. You're not going to see overlap between this, but this represents all the solutions that would make one of these statements true. So an OR statement means only one of the two or more statements needs to be true. When I get to part D, parts D and E are very similar to each other as far as structure goes. Notice it's basically, it has two different inequality signs in it. And I basically have three statements. I have a statement, inequality sign, statement, inequality sign. Same thing here. The difference is this one only has a single x. This one has multiple variables. So this one's a little trickier than this one. This one I can handle pretty easily by kind of doing something similar to I did with the rest of them. This basically is saying that 6 minus 2x is between negative 4 and 4, including the negative 4, but not including the positive 4. So what I want to do is I want to solve this so that, I have x in the middle. So what I want to do is isolate x in the middle. So what I'm going to do for this one, if I have, just the variable, expression in between the two inequality symbols, then I'm going to subtract 6 from all three parts, which would give me a negative 10 is less than or equal to a negative 2x, which is less than a negative 2. And now I'm going to divide everything by negative 2. Much like it was for the single inequality where I just had a left and a right, the inequality signs have to get switched here too. Negative 10 divided by negative 2 is a positive 5. This becomes the greater than or equal to symbol. This becomes an x. This becomes a greater than symbol. And this becomes a 1. Now typically when we write this, because, basically what it's saying is x is between 1 and 5, not including the 1, but including the 5. So, this is kind of like an in-between. Communication setup here. And so my solution to this is to have open-ended dot here, close-ended dot here, and I go in between them. This is an example of an AND statement. Whenever possible, we try to write an AND statement, not using the word AND, we try to write it in this in-between format. When we get to situations like E, that gets a little bit more complicated to leave it that way, because me doing something to any of the, variables on one side of the inequality or another, or one part of the inequality or other, is going to leave parts in other parts. So when I deal with a situation like this in E, I'm going to take this inequality, 3a is less than 4 minus 5a, and I'm going to split it up and say and 4 minus 5a is less than 5 plus 3a. So, this in-between structure is an indication that I have an AND statement. An AND statement means that I'm able to do both at the same time. Like here, it's like me saying, I could have wrote this as x is greater than 1, and x is less than or equal to 5. There are numbers, and means that both of them have to be true at the same time, which means that I have to choose numbers that makes both of these true at the same time. So, for instance, the number 2, it's more than 1, it's also less than or equal to 5. That works. 5. 5 is less than or equal to 5, it's actually equal to, it is more than 1, so both work. So an and means that both parts or all parts have to work versus an or statement, which means that only one statement has to be true. So for these, I'm just going to solve these. For the first one, I'm going to add 5a to both sides. I'm going to end up with 8a being less than 4. Dividing both sides by 8, I get a is less than 1/2. No multiplication or division by negatives happens, so we're good. This is just going to be brought down. For the next one, I'm going to add 5a to both sides. I'm going to have 4 is less than 5 plus 8a. Subtracting 5 from both sides, we're going to have negative 1 is less than 8a. Dividing both sides by 8, I have negative 1/8 is less than a. And basically that means that a is greater than negative 1/8. Now notice, I did not flip or change the inequality. The inequality always had a being more than negative 1/8, and I'm still representing that here. I just want to make sure I know what's going on as far as this and statement goes. I want to be more than negative 1/8, but I want to be less than 1/2. So that means I can rewrite this essentially as a being more than negative 1/8, but less than 1/2. As far as writing it as a compound inequality, uh, 1/8, 2/8, 3/8, 4/8, 1/8, 2/8, 3/8, 4/8. A negative 1/8 would be here. And so if I graph this inequality, I would have an open circle here, an open circle here, and I would shade in between them. And so those are the graphs and the solutions to these various inequalities. So I'm not doing anything majorly different than what I would normally do when I'm solving equations, and that's simply just trying to get the variable alone on one side of the equation, or inequality in this case. The only exceptions are these in-between ones where I sometimes would have to do it in do 3 different parts, or I could separate it into 2 and statements. That's fine. And the only difference between doing these inequalities and solving an equation is that, you know, the remembering to switch around the inequality sign in those instances where I multiply or divide both sides by a negative. Now let's see how we can make some use of these and apply this knowledge to some problems. So for example 2, we have Acme Movers, which charge $100 plus $30 per hour to move a household across town. Hank's Movers charge $55 per hour. So basically no initial fee. For what interval of moving times does it cost less to use Hank's Movers? So basically, you know, if it's going to be a big move where you have to take like a lot of items out, and you know, it's going to take a long time to move them, you know, it may be more cost effective to use one over the other. So the way that they're asking this question, they're saying, okay, for what interval of moving times does it cost less to use Hank's Mover? So I'm looking for instance where Hank is less than Acme. Now I need to come up with some expressions for this because I'm going to let X represent the number of hours needed to move. So when I look at Acme, they charge $100 plus $30 for each hour. So if I want to figure out how much they're charging, I would take 100 plus 30x. Hank's movers would be 55 times x. So for instance, if I looked at these two, I said, okay, well, say the time took 1 hour. That had to be a pretty small house, but say it took 1 hour. Then Hank would be charging $55. Acme would be charging $130. So obviously Hank in that instance would have a situation where that is going to be the case, that it's going to be lower. But as I move along, his rate per hour may start making him more expensive the longer the time is to move. I also have to keep in mind, it doesn't make sense to really have anything in the negative territory. So I'm going to have to put some limit at 0 for this. Okay, so that means I'm going to have 0 is less than 55x, and 55x is less than 100 plus 30x. So obviously for this one, that means that 0 would be less than x. X has to be greater than 0. Stands to reason. If it doesn't take me any time to move, then I'm really not moving anything. This one here, the right-hand side one, which is basically this inequality here that I was mainly looking at before, I'm now going to look at and try to solve this for x. So I'm going to subtract 30x from both sides. And I'm going to end up with 25x being less than 100, dividing both sides by 25. I'm going to have that x is less than 4. So basically, for any move, less than 4 hours, Hank's movers cost less than Acme movers. So if you get 4 hours, if it takes 4 hours for you to move, they would both be charging you the same amount. If it's over 4 hours, then Acme would start being cheaper than what Hank is charging you. So that's how you would kind of make a decision. If you could figure out how many hours you think it's going to take you to move, that would help you figure out, who to go with if you want to save money. Let's move on to example 3. So here is another application problem. This one's dealing more with money and percentages again. So again, we have to be very careful about how we do this. A university invests $600,000 at simple interest, part at 6%, half that amount at 4.5%, and the rest at 3.5%. What is the most that the university can invest at 3.5% and be guaranteed $24,600 in interest per year? This gets a little tricky because the thing they're looking for is the amount invested at 3.5%. So I'm looking to figure out what's the most that they can invest at that in order to guarantee getting $24,600 in interest per year. And that means that, it's probably at least. I want at least that amount. So the issue we have with this is, we have basically three amounts. I'm going to let x, starting off, be the amount at 6%. I'm going to let y be the amount at 4.5%. And I'm going to let z equal be the amount at 3.5%. And right now I want, the interest. I want 24,600 in interest. So basically I want 0.06x plus 0.045y plus 0.035z. Let me scooch this over a little bit. I want that to be greater than or equal to $24,600. The problem is I have three variables in this setup. So what I need to do is figure out a way to get this in terms of only one variable. And then I eventually need to figure out what, ultimately I want to figure out what z is. So let me put a little star right here. This is what I want to figure out. I want to figure out what z is. That doesn't necessarily mean that when I set up this equation, that's what I'm going to find immediately. And that's the one thing you have to kind of, be aware of, is that sometimes when you set up these equations, the thing you're looking at, the thing you might be solving for, is not necessarily going to be, when you solve that inequality or solve that equation, that's not necessarily going to be the thing that you're looking for. So I got to use some other facts that are in the problem. So I know that the amount at 4.5% is half the amount at 6%. Because that's what it says. It says part of it's at 6%, half that amount at 4.5. So I know that y equals 1/2 x. I know that x plus y plus z is $600,000. That's the total amount invested, which means that x plus 1/2 x plus z equals 600,000. Put a zero there. So these two become 1.5x, which means that z equals 600,000 no parenthesis minus 1.5x. Now I have everything in terms of x, which means I can substitute into this equation up here and say, okay, now I have 0.06x plus 0.045 times 1/2 x plus 0.035 times 600,000 minus 1.5x. And again, I'll just scooch over a little bit here. and that's going to be greater than or equal to 24,600. So, I'm going to try to solve this inequality for x first. So, 0.06x plus 0.0225x plus little computation here, 0.035 times 600,000 is 21,000. Negative 1.5 times 0.035 is 0.0525x, greater than or equal to 24,600. I'm going to combine all my x terms together. So 0.06 plus 0.0225 minus 0.0525. It's going to give me 0.03x plus 21,000 should be greater than or equal to 24,600. I'm going to subtract 21,000 from both sides. And I get 0.03x is greater than or equal to 24,600 minus 21,000 is 3,600. Divide both sides by 0.03. X is $120,000 or more. Now, some of this you have to kind of figure on some things here. The amount invested at 6% is greater than or equal to 120,000, which means this is greater than or equal to 60,000. It's always half the amount invested the other one. If these continue to increase, because we're saying it could be $120,000 or more, and since if X keeps increasing, that means Y is going to keep increasing, but it still should total 600,000, which means Z would have to be decreasing. So when I look at this, and I'm going to use this X value of 120,000, I get that Z is going to be 600,000 minus 1.5 times 120,000. And as again, if this can keep going higher and higher, just keep going up, this has to keep going down. So that's the most I can invest at $420,000 at that amount in order for this to clear 24,600. If I have more than $420,000 in at the 3.5% interest, I'm not going to get $24,600. So the answer is that the most And I'm abbreviating as 420,000 with K because I'm just running out of space. And so that would be your answer right here. And that is the end of this video. If you have any further questions with 1.6 or anything now in Chapter 1, please make sure to reach out and let me know and get some additional help. Until I see you in class, have a good day, everybody.